All right, watching TV. Choose a young person aged 19 to 25 at random and ask, in the past 7 days, how many days did you watch television? Call the response X for short. Here is the probability distribution for X. So here's our probability distribution. What is the probability that X is equal to 7? Justify your answer. Okay, so part A. Uh, we know that the sum of these probabilities must be 1. So 0.04 plus 0.03 plus 0.06 plus 0.08 plus 0.09 plus 0.08 plus 0.05 plus the probability that x is equal to 7, they all have to equal 1. So if I were to add all these together, I would get 0.43 plus the probability that x is equal to 7 is equal to 1, right? And then, of course, I can subtract 0.43 on both sides to get the probability that x is equal to 7 is equal to 0.57. So the probability that x is equal to 7 is 0.57 because the sum of these probabilities must be 1. All right, part B, calculate the mean of the random variable x. Okay, so the mean, right, mean of x is the same thing as the expected value of x, and we have a formula for the expected value of x. It's going to be 0 times 0.04, right? 0 times 0.04 plus 1 times 0.03 plus 2 times 0.06 plus 3 times 0.08 plus 4 times 0.09 plus 5 times 0.08 plus 6 times 0.05 and then plus 7 times, and we got 0.57. So if we are to do this math, this will give us a value of 5.44. So this is what this means in the context, right? Okay. So this is what this means in context. If we were to select many young people and ask them this question, right, how many days they watch TV, we would expect the average number of days to be 5.44, right? Okay. Now, let's see, part C. Suppose that you ask 100 randomly selected young people to respond to this question and found that the mean of their responses was 4.96. Would this result surprise you? All right, so this group of 100 people, their average is 4.96. Okay, so now let's see if that would be surprising. So C. So we know for the sample n is equal to 100, and we're trying to find, we're trying to see the probability of this mean, right, being less than or equal to 4.96. So right off the bat, I know that n is equal to 100, which is bigger than 30, right? So this means by the central limit theorem, right, that x bar is approximately normal, where the mean of x bar is the same thing as the mean of x, which we found earlier, and the standard deviation of x bar is going to be the standard deviation of x over the square root of n. Okay? So now we got to find our standard deviation for x bar. All right? So remember, variance, right? The variance squared, this is equal to the variance of x, right? And this has a formula that we like to use. This is the expected value of x squared minus the expected value of x, and this thing is squared. So we already have the expected value of x. We have to find the expected value of x squared. Okay? So we know this is equal to, so the expected value of x squared is going to be 0 squared times, so 0 squared times 0.04 plus 1 squared times 0.03, and so on, right? All the way to 7 squared times 7 squared times, oh yeah, it was 0.57, right? 0.57. And that is all of the expected value of x squared, and then minus, and then the expected value of x, remember, was that 5.44 squared. And if we were to do this calculation, it would give us 4.5664. All right, so now we have that the standard deviation, the variance of x is equal to, of course, the variance of x, and that's equal to 4.5664. So this implies that the standard deviation of x, right? The standard deviation of x is equal to the square root of the variance of x, which is equal to the square root of 4.5664. And this is equal to, let's see, 2.14. Okay? So as you can see, I have my conclusion here. So I have that x bar follows an approximately normal distribution with the mean of x, remember, was 5.44, and the standard deviation of x bar is the standard deviation of x, which we just found is 2.14, over the square root of n, which is 100, and this turns out to be 0.214. So remember, we're trying to find the probability that x bar is less than or equal to 4.96. And then since x bar is approximately normal, we can standardize it, right? Less than or equal to 4.96 minus the mean of x bar, which is also the mean of x, which was 5.44, over the standard deviation of x bar, which was 0.214. And then this is equal to the probability that z is less than or equal to negative 2.24. And then we can go to our table and find it, which I already found for us. So negative 2.24, which is 0.0125. 0.0125 equal to 0.0125. So the probability that this x bar is indeed less than or equal to 4.96 would be about 1.25%. So definitely, if I was given this study, right, based off of this probability distribution, if I was given this study where they randomly selected 100 people and their average was 4.96, I would say that that group of people, their average would be low, right? So yes, I would be surprised because the probability that this average from these 100 people is 1.25%.